Hello, guys. Hello, everybody. Hello, I'm coming back for my live streamings. Okay. Wait for a while, a moment from now. I need to begin my discussion about chemistry. This time we go to science. Hello guys, hello everybody. Good morning. Happy Saturday to each and every one of us all over the world, parts of the world. This is your YouTube content creator, Engineer Sotero Nepomuceno Jr., Occupational Safety Health Engineer, and also a vlogger. Okay, so I've been discussing a lot pertaining to English language. Now it's about time to shift topic because I miss, vlogging about science. So again, my favorite. So let's go back to chemistry. So this is very important in our practical life in day-to-day basis because we cannot avoid various chemicals in our schools, in our companies, in our factories, households, in homes. You can really meet various substances in which we use in daily basis. And then we are not aware really what are the hazards for these particular substances. Then we need to identify the physical and chemical properties, but most of the times we need to determine in terms of its polarity and non-polarity. So with regards to the relationship versus polarity and non-polarity, we can identify if the compounds are really exclusive, reactive, toxic, flammable, and there's a lot of hazards for that, right? Whether it could be fatal, injurious, detrimental, with beneficial health effects for us. Okay, because not all chemicals are bad, are harmful, but some chemicals are very important in order for us to be alive. Right? Things like that. So, in this particular topic, we will be able to tackle about polarity and unpolarity. Then, as we can remember in our general chemistry lecture 1 and 2, so this topic is not really the basics because it's in the, I think, chapter 2, chapter 3, chapter 4, but it's not in chapter 1, I'm sure for this. Okay, so this relates to the chemical banding. Okay, so let's try to be specific here. We need to discuss the polarity and unpolarity. Then it has to do something with covalent banding. Okay, because in covalent banding, we need to understand really the sharing of electrons. In the sharing of electrons or transfer of electrons, we can determine really if the compounds or substances are really polar and non-polar. Then, if we will determine if it's non-polar, there is something to do if it is flammable or not. And if it is polar, there's something to do if it is really conductive to metals, if it's really conducting electricity. So through that knowledge, so we're aware, right, technically and academically. So it gives us awareness and information to save also our lives in a scenario in which it's very difficult to manage, especially if we're working in the hazardous laboratory or in any place that involves the application, the utilization, and the usage and handling of various hazardous substances and chemicals, right? Okay, so that's very long introduction, right? Because I am very wordy and I'm very verbose, that's why. Forgive me for that. Okay, let's erase this because it's still vocab 4 in English language. I discussed this yesterday, right? Okay, I may erase this. So I have here the rag. The rag is my eraser because I have the eraser, but it's not effective already. So it cannot erase the writings in the whiteboard. That's why it's better for me to have the rag, right? And I moisten this a little bit, and then easily it can erase the writings. Okay. Okay, I may erase now and change to another topic. Okay, now, so if you are students right now listening to me, so this may be applicable to you if you are now in a junior high school or a third year high school, because this topic for sure is really discussed from your chemistry teacher. Okay, things like that. But I need to add clear and easy to understand techniques that most often taking for granted during the discussion, because our chemistry teacher have lesson plans and they have to meet that lesson plans. Then sometimes they could not elaborate in an elucidation manner, meaning discussing it very clearly. That is elucidation. Okay, in English language. Okay, so for example, if you elaborate, then you need also to discuss it explicitly, okay, clearly, with clarity, and you be able to introduce also technique. Okay, as an instructor and professor and teacher, we should not be selfish. We need to teach them, our young students, what are the techniques really? Okay, so because what's this after all? Okay, we are passing in this earth, and we need to give the crown to our predecessors, the younger generations, to transmit our knowledge to them, right? So to improve our economy of our country, like that. So we will be passing, it could not be denied, right? So we need to share our knowledge, and as much as we could, we need to share our technique, right? Techniques, how to, for example, how to solve properly with regards to mathematics, like that, or anything, right? So things like that. These things cannot be bought by money, okay? Regardless of everything. So, this is very fruitful and you will feel fulfillment after your discussion, because you give your everything, your heart, even though you are not paid to share knowledge, things like that. You get the point? Okay. Now we start with our title will be the polarity versus non-polarity. Okay, where's my, okay, it's here, right? Okay. Now, we need to review first the very basics, okay, of the compound. So we have two types of a compound. So two types. So you can also write in the blank sheet of paper, two types of compounds. Okay. So this means generally. Okay, generally. So we have inorganic compound. Okay. Or I will just abbreviate this as CPDs, compound, and then organic compound. Okay. So to discuss a little bit overview, inorganic compound, okay, it excludes the study of carbon. We just treat this in a simple manner. If we say organic compound, we include the study of carbon. Kalas. That's it. Okay? For me, that's only the basic identification without lengthy definition. You get the point? But if you want a detailed information, that's not our topic. Right? Okay, so it will extend my time too much. Because this is my weakness. I will extend my time of too much discussion in my vlogs. Because I am more on the content-wise. I am not on the visual effects, animation, laughter, dancing, like that. But I can be in singing, right? You get the point. So two types of compounds, okay, okay, based on, okay, chemical bonding. Okay. Okay. Two types of compounds based on chemical bonding. This is not specific. Okay, your answers will not be in organic compound. It could be one molecular compound and a unique compound. Okay. things like that. Now, since we're dealing with chemical bonding, so we need to discuss about the sharing of electrons, and the transfer of electrons. I will just put Se and Te, meaning Se sharing of electrons, Te means transferring of electrons. Right. Now, when you do this, you can easily identify if the compound is molecular or ionic compound. Things like that. Okay, but in here, in organic compound, it doesn't deals with chemical bonding and chemical reaction. Automatically, you can say, oh, that's an organic compound because it is not studying carbon compounds. Oh, okay, that's organic compounds because it studied carbon compounds like that, okay? You get the point. So we will not go in these details. We will go for these details. Now, in this second here, two types of compounds based on chemical bonding. So, our title of this vlog will appear. The polarity versus non-polarity. Okay. Polarity versus non-polarity. Okay. You got the point. Okay, this is our title of our vlog for today. These are only our introduction, a lengthy introduction. Okay, because this is my style. I always have that since high school, college, like that. So I'm talking too much before going directly. This is my weakness sometimes, okay? I'm very detailed. You get the point? I need to elaborate more in my discussion. It's not really enough for me to go directly because, for me, there's no clarity that much. That's my intention. Okay? Things like that. And I'm now trying to erase this all. And we understand now that the topic is polarity and non-polarity. Okay, you got the point? Now, if you speak about polarization and non-polarization and polarization, it talks about electrons. Okay? It talks about atoms. The relationship between the atoms and the electrons are very clear in the discussion of polarization and non-polarization, or polarity versus non-polarity. Okay, now we will attach chemical bonding here. Okay, now what is the basic theory that involves chemical bonding? So if we go back to our chemistry lecture, we have Arrhenius' theory of acidity and basicity, Bronsted-Lowry of basicity and acidity. Okay, we have also Lewis' theory of acidity and basicity. So Lewis is very popular because it's in that we need to attach chemical bonding. Okay, you get the point? So when we mean of Lewis acidity and basicity, it has to do something with Lewis diagram or the Lewis dot structures. Okay, this is more on organic part, right? And then the Arrhenius theory or Bronsted-Lowry acid and the base, things like that. It's more on inorganic study. Okay, I am doing the categorization. Now here we need to touch with Lewis diagram. This, if I'm going to attach, the details, it will take me 2 days, 3 days to finish. Sometimes I need to go directly a little bit, though I am detailed, but sometimes also, right? Because sometimes I will discuss this, and my time will be consumed. You get the point? Things like that. This is only my weakness because I don't have professional education, effective methods how to do the teaching. This is informal teaching. You get the point? So I don't go by the strategies in effective teaching. Okay, let's make this a clear situation that's gonna be like that. Okay, so I'm not a legit professor and instructor. Okay, I'm just a vlogger. Okay, things like that. So we have Lewis diagram. Okay, things like that. Okay. Now, Lewis diagram, so it talks about electrons. So first you need to understand what is electron all about, right? So electrons are light particles in the outermost shell in the nucleus. okay, with a negative charge 1 with a mass of 9.11 times 10 to the negative 31 kilogram. That is the mass of one electron rotating in the outermost shell of the nucleus, okay, under the study of John Dalton atomic theory. Okay, there's also proton and neutrons, but that's not our concentration for today. Our concentration is electrons. So if there's an electrons flow, electricity will be induced, things like that. Or we can create electricity because of the electrons flow in a path, things like that, in a wire or whatever, things like that. Got a point? Things like that. Now, so we need to study the valence electrons for this. Okay? You get the points of valence electrons. Electrons in the outermost shell. And this is the basis of our electronic configuration in our periodic table. So let's go directly, let's say, from 1, 2, 3, 4, like that. If you can remember, right? Like this, our periodic table. Things like that. Okay. This is arranged properly by Dmitry Mendeleev according to the properties, chemical properties and physical properties with increasing atomic weight. Things like that, okay? Atomic size. As you go from left to right, it will increase the atomic size and atomic weight. Things like that, okay? And also the atomic number. I don't have to discuss that. Others, electro affinity, electronic negativity, things like that, okay? Electronegativity, ionization, you get the point? So ionization energy, things like that. So there's a lot, okay? But, you know, let's be specific to electrons and atoms, right? Things like that, okay? Okay, things like that. Here is the transition elements, here. So it's in here that we can find the semiconductors, elements used in electronic industry, okay, in making cell phones, mobile phones, laptop. Here, semiconductors or the metalloids, or the transition, meaning it will shift to another appearance or form. It will act sometimes as a metal, it will act sometimes as a non-metal, it will act sometimes as a liquid, it will act sometimes as a solid at a certain parameters, let's say temperature, pressure, like that, under circumstances, physical properties, things like that. Like mercury. Mercury can also exist as a liquid, can also stand as a gas, like that, or solid, okay? You get the point? And then it's in here in terms of transition group. Metalloids, semiconductors, metals, and everything. Okay. This is not included in our numbering of our valence electrons here. We go here. They have also electrons, but for the purpose of the specificity of our topic, which is Lewis diagram, we exclude this transition, okay, metals. We go directly here. Okay. 5, 6, 7, 8. So these are what we call as, okay, you remember this one? Okay, group A, group B, group C, group D, group E, like that, blah, 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 or group 1, group 2, group 3, group 4, group 5, group 6, 7, group 8. So group 1, let's say alkaline or alkali metals. Group 2, alkaline earth metals, things like that, okay? And then group 7, okay, let's say halogen family or halide family. Group 8 is the noble gases or the inert gases, things like that. You get the point? Okay. Now, this 1, 2, 3, 4, 5, 6, 7, 8 represents also the number of valence of electrons, which is very useful to the detection how polar and nonpolar our substances really are. Okay. Now, there's elements in 8, 7, 6, 5, 4, 3, 2, 1. You don't have to memorize everything. You need only to memorize the most common elements in your periodic table. At least 50 plus elements you will memorize out of 118 elements in the periodic table. If you can still remember, we have 118 elements in our periodic table. Review, stock knowledge, right? Things like that. Correct me if I'm wrong. Okay, now, erase. Okay. Now, since to make this a little bit simpler, we need to start with water. Okay, because water is life. Without water, we will die. Then we need to determine the chemical properties of water. Okay. So, water first, no? So, water is highly conductive to electricity. It can cause electrocution because it conducts electricity. Because this is a polar compound. So, water is the representative. So, it's going to be like mostly or all. I'm not telling that all because I don't have the experimentation in the laboratory or analysis, but let's go by the theory that it could be polar compounds are conductive to electricity. And water is the best example and the rest will follow. Okay? The more it will become polar, the more the rest of the substances will be highly conductive to electricity. Things like that. You get the point? Because there's a lot, right? Not only water, but we start with water because this is the simplest and very essential for our cellular respiration and for our life here on Earth. Okay, the planet Earth will not survive without water, and the human being also will not survive without water. So it's very important to discuss about water, right? So physical properties of water, right? Things like that. Aside from that, water is having a boiling point of 100 degrees Celsius. Okay, freezing point of 32.2 degrees Fahrenheit, and 0 degrees Celsius freezing point. Things like that, okay? You get the point? Get the point? Okay, so stop for now. Now we go now to our Lewis diagram. Okay. Now, if we say oxygen, so it's in the number 6 of our group a while ago, in which I discussed. So 6, meaning to say oxygen has 6 valence electrons. Okay, so VE. Okay, hydrogen, so it's in the group 1, meaning to say 1 valence electrons. Okay, now we have water. Okay, so how many atoms of hydrogen in water? Okay, and how many atoms of oxygen in the water? Things like that. So if I ever ask you, how many atoms in water? Can you answer? Okay, if I will say, how many atoms in hydrogen in that water? How many atoms of oxygen in that water? How many moles of oxygen in that water? Can you answer? How many moles of hydrogen in the water? Can you answer? What is the mass of oxygen in that water? Can you answer? What is the mass of hydrogen in that water? Can you answer? Even though there's no data, you can answer by concepts of theoretical knowledge, basic foundation in chemistry. It doesn't mean that there's no data, there's no number, there's no numerical figure. You can never answer anymore. You get the point? So you need to think of a certain standards conditions in order for you to answer. Mostly examinations are like this. Sometimes there's no given, but they're asking for a numerical figure because we have standard conditions. Okay, we have the basis of our calculations in that matter. When we say basis of calculations in our problem solving, we need to attach that always at standards conditions, things like that, okay? Get the point? So if we say we have the temperature parameter, we have also the pressure condition. So this is at STP, standard temperature and pressure. In this alone, even only compound will be mentioned, asking of everything. What is the viscosity of water? What is like blah 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 so on so on. There's no given at least one numerical figure in the problem. This is very strange in an examination. Usually it's a trap and tweak for some students, especially for students that who always rely to the sample problems of their teachers and instructors. It's not like that, okay? We go beyond from the sample problems of our instructors and our professors. The only way to do that is to extend our learning out from the classroom of instructions you go to the library, okay, and study a lot, or you can even go to the public library in your place and research a lot for that particular topic, because it could not be denied the discussion of our instructors and professors are limited to that specific context only. The linkage, the collaboration of other topics, you could not expect that they discuss that there, because sometimes limited hour only. Me, I have the full time to discuss everything because this is not a school. I have the privilege to be lengthy in my discussion. And then if I am given a chance also to become an instructor someday or professor someday, I will just also adjust my time. So this is the drawback. So you as a student will never rely 100% from your instructors and professors. It can only give you the most basic foundation, but other than that, you could not expect, okay, that they will try to spoon feed you everything. You need to be resourceful. You need to have your own initiative in order you will become a legit engineer in the future. You get the point? What do you mean by legit? Registered and licensed engineers in the future. I'm not saying that the students are graduating in engineering are not legit. What I mean, it's only by documentation by the government to practice the profession. You get the point? Things like that. This is subjective. Okay? You get the point? Subjective in explanation. We cannot summarize because every individual, have different knowledge and competencies. Maybe they are better than me. Okay? Then it just happens that I discuss a lot. Things like this. You got my point. Okay? So, we go back now here. So, we have here the water, right? Okay. So, how many atoms of hydrogen in the water? So, 2 times 1 is equal to 2 atoms of hydrogen. We need to discuss this so that we can understand before starting the Lewis dot structure. Overview. You get the point? Then, 2 atoms of hydrogen. You don't have to put H2 because this is elemental constituent. When you break down the elemental constituent, you don't need consider the subscript. Okay, so chlorine gas, Cl2, H2, F2. You don't say H2 when you say the number of atoms. It's only H, F, Cl. Okay? That's gonna be like that. Okay? I said 2 atoms of hydrogen. I'm not saying 2 atoms of hydrogen gas. Okay, if you try to break as per elemental constituents, meaning element by element in that particular compound. Okay, say oxygen. Okay, we have 1 times 1, so 1 atom, of oxygen. Things like that. So how many atoms all in all? 3 atoms. If you try to be strict, there are 3 atoms of water. Okay? Because it's coming from the hydrogen and oxygen. But it looks like strange because nobody teaches you in this way. Because this is only my own initiative to teach in this way. Because this is another style of teaching attacks. You get the point? So, you need to understand really what is atom. You get the point? Apart knowing the descriptive definition, atom is the smallest and tiniest particle in the nucleus. And that is a statement definition. Okay, but here is an elaborative definition. Okay, by discussion, by structuring, blah, 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 so and so. Okay, got the point. Now, if you will say, how many number of moles of water? So, you will say, 1 mole of water. This one. 1 mole of water. Or we can say that also, 1 molecule of water. Okay. So it's very understandable that molecule and atom are not the same. Mole and atom are not the same. Things like that. You get the point? Ganon. So, if you try to break this one, 1 mole of oxygen, like that, okay, and 1 mole of hydrogen, so, things like that. You need to explain in that way. You got the point? Ganon. Okay. Now, we go now to the Lewis diagram. Okay, as I said, water, right? Now, before you draw the Lewis diagram, it will be based on the dots. Dots, D-O-T-S. The dots there are the valence electrons. Again, the dots there are the valence electrons based on the group in the periodic table. So I have water, then you need to break hydrogen and oxygen. Dun, 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 dun. What is the valence electrons of hydrogen? 1. So valence electrons. What is the valence electrons of oxygen? 6. Right? Because it's in the group 6. 1 because it's in group 1. Okay, things like that. Now take note your compound here. If there is subscript here in your compound, you need to multiply each. If there's no subscript, treat that as 1. And it's very clear. It's not 0, huh? Treat that as 1. Now, it's very obvious in your oxygen. 1. So times 1. You get the point? Things like that. Okay. So, 6 times 1. So, if you have the valence electrons here in your first column, in your second column will be the atoms. Okay. Like that. So, your atoms will be, it's here, 6 atoms. Now, for hydrogen, so valence electrons, 1 times 2 because they're subscript. So 1 times 2. This is 2 atoms. So this means this is subscript. Right? Nobody teaches in this way. Subscript. Because this is very important to learn. Okay, so subscript times 1. Subscript times 2. Like that. So 2 plus 6, because we are concentrating on the atoms, 8 atoms, 6 plus 2. So 8 atoms. Okay, you got the point. Ganon. Okay. You get the point. Okay, valence electrons plus 2 atoms. So this is not atoms, 8 electrons. Okay, 8 electrons because it is the product already. See? Product. Okay, so 8 electrons. Okay, you get the point. Now, in your water, you have 8 electrons. Huh? So total of 8 electrons. Okay. Now, in your diagram, Lewis diagram, you need to attach chemical bonding. Okay, chemical bonding. Okay. So chemical bonding, we can determine the polar and the non-polar compound. Okay, versus non-polar. Okay, like this. Okay, now we need to draw now the Lewis did structures. Okay, for water. So I need to erase now. Just put this into your brain cells because this is not difficult, right? Very basics in chemistry. Okay, get the point. Things like that. Now, we have here water. So in this manner, if you can see a compound, to extract first the subscript. The more it has become subscript, the more it will be scattering into your Lewis diagram. The more it contains the smallest subscript, then the more it will be in the center of your Lewis diagram. You get the point? Again, if there is subscript of that particular element in the compound, take the subscript as your basis when you draw the Lewis diagram, electrical is in my brain. Okay, things like that. And the center will be the least number of subscript. Okay, here, the least number of subscript is oxygen. And the more subscript is 2 hydrogen. So your hydrogen will be spreading out and the center will be oxygen. Again, oxygen, hydrogen here, hydrogen here. This is the first requirement. Again, consider the subscript. The more subscript, the more it will be spreading out. Okay? And then the center will be your element that contains the least number of subscript. Okay, it's very clear, right? Now, hydrogen, we said before, that's 1 valence electron. So put that 1 dot. Hydrogen, 1 dot. Because 1 valence electron. Now, oxygen, 6. Right, so 1, 2, 3, 4, 5, 6. Now we have now the dots. Okay, now, involve now the sharing and the transferring of electrons. Okay, in here it's very easy that there's a single bond or one short line only between H and oxygen attached. Oxygen and hydrogen attached like this. Okay, things like that. You got the point? Okay, now remember your octet rule for this. Octet rule meaning when you count the banded electrons, it will not exceed from 8 electrons. Okay, you count it. But in here it's very easy because it's less than 8, the water. Okay. 1, 2, 3, 4, 5, 6. This is the original valence electrons of oxygen. And the 2 electrons will be shared with the one hydrogen in the other side and the other one hydrogen. So in here, we can say 4 electrons unpaired or not being shared. Okay. And then, we cannot say directly how many electrons are shared because it's not equal in the sharing. There's no equal sharing of electrons. There's an excess. So you will say, what are the shared electrons with respect to hydrogen? What are the shared of electrons with respect to oxygen? You will do it individually. You cannot generalize because there's an excess of electrons. Then you have to break down that. Okay, how many shared electrons of hydrogen? Okay, it's here, right? Like that, shared. 1, 2, 3, 4. Hydrogen 4. Okay. Hydrogen 4. Oxygen 1, 2, 3, 4. 4. A total of 8 electrons. So it is under the octet rule, which is 8 electrons being shared by both. But it doesn't mean that there's an equal sharing of electrons. There's an excess or unpaired electrons. Now, so there's an excess unpaired electrons. So this is polar covalent bonding. And now our theoretical arrives. Theory. So polar covalent bonding, a chemical bonding that have excess unshared electrons. So see, we can create our definition after illustrating the structuring, the elaboration, things like that. So that we can understand before making our own definition, not plain memorization. Okay, so that we will not forget that for how many years. Just like me, I just learned this 30 years ago, but I could still remember until now, even though I don't review. I don't review, I'll go directly with the vlog. As long as I will think what are the vlogs I'll be able to do now, then I have to vlog. You get the point? So there's no need of review if it was stuck to your brain cells because you understand it fully. You got the point? So that's why, it's difficult for me to share this. When you learn something, it's not only for the purpose of impressing your parents because of your good grades. You will learn something so that you can apply that in a day-to-day basis, and you need to apply that in the actual, in reality of the world. So this kind of learning outcome will never be forgotten until your last breath. Things like that. You get the point? Okay, but I think it depends on the standards and the intellectual capacity of any individual because there's also slow learners, not all are fast learners, right? But really this is really the purpose. Our education, we need to apply that, not only in school, but in outside environment, the total framework and portfolio in learning. You get the point? Our knowledge, it will never stop in the school. The application is in the real world, the practical application. You get the point? Things like that. So in that way, you don't need to memorize plainly by the book. Okay? You don't need to be bookish. You get the point? Things like that. Okay, now, we have 8 electrons, so it's a compliant of the octet rule. It contains only a maximum of 8 electrons. Okay? In your octet rule. Okay. for your chemical bonding. Okay, things like that. So this is now the polar covalent band. Okay, since water compound exhibit a polar covalent bond, so water molecule is highly polar. Okay, now if there's an examination in the future and then distinguish which of the following is the only polar compound, A, B, C, D. So it's very easy for you to do that. You will be perfect. Sure. If the question is only like that, I can guarantee you will be perfect. If you know how to do the dot structures. There's no complexity in that. Okay? By doing this, yes, automatically propane is a nonpolar. See, I don't do the structure, but I can still remember that it's nonpolar. Okay, you get the point. All hydrocarbons are nonpolar. No need to structure. Okay? Because it is highly theoretically proven in the laboratory analysis and experimentation that it will exhibit really non-polarity. Okay? In the laboratory analysis and experimentation in the small-scale laboratory. Things like that. Okay? Get the point? Okay. But for the purpose of discussion, I need also to introduce at least one example of nonpolar compound. Let's start with propane. It's the most popular. Propane is used as our LPG, liquefied petroleum gas, the orange color in our kitchen, or let us say the blue or the light blue. That is LPG, liquefied petroleum gas, mainly contains propane. Let's do the structures of propane now. Okay, so that we can say it's propane is polar compound or non-polar compound. So the only way to be sure and confirm, then we need to do the Lewis diagram. Lewis the structure. We don't need to guess. But if you trust your stock knowledge before in your general chemistry lecture 1 and 2 in the past, no need to do that structuring. You got the point? Things like that. Okay. Now we have propane, C3He. Okay, take note the subscript. Which is more? Carbon or hydrogen? Carbon. So carbon will be in the center. Okay. Carbon is in the group number 4. Oh, you will say 4 valence electrons. 1, 2, 3, 4. Like that. Okay. Hydrogen is only 1, but there's 8 spreading. You get the point? Things like that. 8 spreading. Okay. You will say 1. Okay. 2, 3. For example, only 4, 5, 6, 7, 8. Now, since you say there is 3 subscript carbon, it's just equal to having 3 carbon atoms in the center. Okay, so you need to adjust another carbon. So you need to add another carbon. So let's explain in another way. I started with the very basic, that's why. Okay, now. So this is 3. Then you have to put 3 carbon atoms. Okay, like that. 1, 2, 3. And the hydrogen is 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Like that. You get the point? Okay. Hydrogen is 1 valence of 2, 2, 2, 2, 2, 2, 2, 2. That's represent the valence electrons. Now carbon 4, right? 1, okay. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now the third step, connect. Okay, connect na. So connection diri-ari, connection diri-ari, connection diri-ari, connect, 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 connect. Now, in this framework, there's no excess electrons. All are being shared. The carbon electrons are all being shared to the hydrogen. You get the point? So this is non-polar covalent band. Okay. Meaning to say, the definition of non-polar covalent bond is the equal sharing of electrons. Okay. Since equal sharing of electrons, so our propane is non-polar compound. Now, since I'm saying a while ago, we take only one representative out of those hydrocarbons from 1 to 12. You get the points? 12. What is 2 12? So do decay. We have methane, pentane, butane, propane, like that. Okay, heptane, hexane, okay, octane, nonane, okay, decane, denane, dudenane. Okay, not dodecane because cane is sugar. Sorry, in the patterning of our sequencing, okay? So, from methane to dudenane. Dudenane meaning 12 atoms of carbon. Here, methane, we have 1 atom of carbon. So, I'm just put that directly, the minimum and the maximum. But the propane will be somewhere in the center. I don't have to discuss that because that is not our specific topic. It will consume our time also. You get the point? Things like that. So, this is non-polar molecule. Okay, now we understand already what is non-polar molecule and what is polar covalent molecule. Okay, things like that. So, meaning to say, if you're trying to be exact and specific, you will say polar covalent, okay, molecular compound. This is the perfect way of saying non-polar covalent molecular compound. Okay. Now, if the question will say, what kind of compound is water based in chemical bonding? Your answer will be polar compound. It's okay. It's accepted. Polar molecular compound is also accepted. Okay. 2 only. Polar molecular compound. Okay. And polar compound. In your answer, you will never eject or remove the adjective polar in your answer. My question is very simple. What is propane? What kind of compound is propane based in chemical bonding? Your answer will be polar compound or polar molecular compound. Not necessarily have to put covalent. Now, if you want to be perfect answer, your answer will be polar covalent molecular compound. But it takes too long in expressing that. That's why in normal examination, you don't have to state everything, the covalent there, as long as there is word polar already. But I am just explaining the full details. You get the point? Things like that. Okay, the same also with non-polar. Non-polar covalent molecular compound. Okay, if it is really non-polar compound or non-polar molecular compound, if it is perfect, you say non-polar covalent molecular compound. Okay, things like that. You get the point? Okay, and then I said molecular and ionic to make also understandable or have a basic knowledge. When you say of molecular, that is non-metal plus non-metal. If you say ionic, metal plus non-metal. That's why ionic undergoes the process of neutralization because they have different charge. The positive, the cation, and the anion. But in the non-metal plus non-metal, not necessarily, because they are the same charge. You get the point? All are positive, yes? Okay, all are positive. You get the point? Things like that. Okay, non-metal plus non-metal is what you say as molecular. Okay, metal plus non-metal is what you call ionic. Example, at least one for the purpose of discussion. So sodium chloride, the table salt that we put in our food, is a, okay, see, ionic compound. Okay, you get the point now. Okay, So, sugar. What's the formula of sugar? So, carbon 12 H22O11. This is the formula of sucrose, the refined sugar, the white sugar, or the table sugar that we have in our kitchen. Right? So, this is molecular compound. Why? Oxygen, non-metal. Hydrogen, non-metal. Carbon, non-metal. Okay. Now we can distinguish between molecular and ionic compound. So it's very easy now to detect. You get the point? Things like that. Then going now to our Lewis dot structure. Okay. Now, let's try to observe the modes of detection of the electrons in different examinations. The examination will say, how many electrons being shared? Okay, if that is the question, that would mean the total electrons being shared. You get the point? And then sometimes they don't put the word total. It's understood already. You get the point? Now, if the question was say, how many electrons shared with respect to this element? How many electrons shared with respect to element? That's another context. You get the point? They will really trick you out because they're measuring your comprehension. You get the point that this is the regulation of the knowledge of all the graduating students. That's why we have gauging the competence during board examination to calibrate really, to regulate really, okay, things like that. Okay, because they cannot accommodate all to practice the profession with so many people who don't have an adequate knowledge how to practice their knowledge, things like that. That's why they need to regulate. That's why Philippine Regulation Commission. So they are regulating the professionals, things like that, with respect to the registration. Okay, things like the government, things like that. So going back, okay, things like that. So if you say, how many unshared electrons? That also means the total number of electrons unshared or exist. Do not wait for the word total because it's just the same. Understood? You get the point? Things like this. Okay, now, how many unshared electrons with respect to one element? How many unshared electrons with respect to element? Okay, things like that. And this is now what we're trying to discuss now. Now, I have another example of a molecular compound, non-metal and non-metal. So we have, okay, sulfur trioxide. Sulfur trioxide. Sulfur trioxide is harmful gas because it will decompose into sulfur and oxygen, and we know sulfur has a very pungent smell. Then out of the sudden you will be suffocated, things like that, and you cannot breathe properly. Okay, things like that. So, and sometimes also it will yield hydrogen sulfide in combination with water, because there's hydrogen atom in water. Then it will transfer to this compound, and it will eat up the atoms of sulfur. He fold out this hydrogen, it will become H2S, hydrogen sulfide. You get the point? So coming from SO3. Okay, under certain circumstances, the particular parameters that they will appear. It's gonna be like that at certain conditions that they will appear. Because if it now will not meet that certain condition, it will not also appear that kind of product. You get the point? Most of the times chemical reactions have certain conditions for that to exist. Okay? That's why we have temperature, pressure, like that. It's not magic. It will just, follow the conditions, the parameter, what we call as physical parameter, based on physical property of substance. You get the point? Things like that. Now, SO3 sulfur trioxide. Now, the first thing to do is to get the total number of electrons not yet shared. Okay? I said not yet shared and not yet also unshared. Okay, like that. So sulfur. Sulfur is group number 6. So 6 valence electrons. How many atoms of sulfur? Only 1, because the subscript is 1. So times 1 is equal to 6 electrons. Okay. Oxygen. Oxygen is in group number 6 also. The same. Okay, so 6 valence electrons. Times, what is the subscript? 3. So times 3. So it's going to be like that. Okay. 18 electrons. So total electrons, we're not doing yet the Lewis dot structure or Lewis diagram, is 24 electrons. Total electrons. Okay. Now, we draw the Lewis diagram. So which is the smallest subscript? Sulfur. So sulfur must be in the center. Okay. Now we remember the octet rule. Octet rule, at least 8 electrons maximum only. Okay, during the chemical bonding. Okay, in the sharing of the two. Things like that. They will never go beyond. Because it's abnormal already. And it doesn't exist in the first place. Okay, got the point? So we have S. Okay, since only one S, so we have only one S here. Okay, oxygen 3, so oxygen 3. 1, 2, 3, because 3 subscript. Only one because only one subscript. Okay, now take the valence electrons. So 1, 2, 3, 4, 5, 6. Okay, your technique, you need to put the electrons, opposite to the sulfur, so it's easy for you to connect during your structuring. Okay, so sulfur, so 1, 2, 3, 4, 5, 6. You don't put the electrons here because there's no oxygen here. So no purpose, you cannot connect that there. Okay, so 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Now connect. Connect. 1, 2, 3, 4, 5, 6. It's correct. Is it correct or not? By doing only the mechanism, patterning, sequencing, it sounds correct. But for the theory and principle and rules, this is not correct. That's why in science, you don't rush on sequencing, patterning, follow the pattern. Math will do, but science will not. Okay, there are rules. For example, in Facebook, there's a lot of puzzle quizzes, numbers, objects. It's true in math, logic, then by God, what's the next, like that. Only like that. But in science, it's not like that. The rules will always dominate rather than the patterning, sequencing, like that. Okay, get the point? Or mechanism. Okay? Mechanism, you need to follow only the steps. What is being done by the other, you should also apply the other. But in science, it's not like that. Okay, so that's why we have rules to follow. In octet rule, see, 8 electrons. And the mechanics is correct. We're patterning everything like that, so it's easy to correct, right? So, count the electrons. It is 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Take note, 12 electrons had been shared between the sulfur and oxygen, and this is wrong because our octet is only maximum 8 of electrons can be shared by both. Now, you need to restructure again your Lewis diagram. I'm introducing the wrong one so that we can really understand. You get the point? Things like that. Now, going back. Okay, since this is wrong, okay, we need to restructure again. Okay, so sulfur. Okay, oxygen. Oxygen, I will put X. Thank ganon. Oxygen here, things like that. Okay, oxygen. 1, 2, 3, 4, 5, 6. Oxygen. 1, 2, 3, 4, 5, 6. This is very good, right? Because this is just like only playing a game, like a children. But you gain with knowledge. So, See that just like again. 1, 2, 3, 4, 5, 6. Diba? It's like again. 1, 2, 3, 4, 5, 6. Like that. Okay. Since you know this is wrong, so you need to connect. We try to connect only one here, only one here, things like that. And let's say only one here also. Now count if it is 8 electrons. 1, 2, 3, 4, 5, 6. It's not yet. So we say we have 8 electrons. So we need to add one more connection or bonding. So it could either be in the top and the right, in the left, as long as you add one connection.